Today we're gonna talk about migration of legacy applications to containers. So first thing we need to clarify from very beginning that there are two main big things that are extremely important to understand. That if you're going to improve your application to run it in more modern way, so the application should be designed to be in a modern way. So if the design or architecture of application has issues, it was designed 100 years ago in a very bad manner, there are no any way to run the application efficiently and the best way it is possible. So thing number one is to fix your application. So that's the topic we covered last time on our JavaDay conference, where we discussed how to cut bigger parts of legacy application to smaller parts to make it scalable, what things to pay attention on, and what to do. So today we are going to talk about next, also very important thing about the environment, so the place, where do you run your application, and how do you handle this application in a way it should be. So legacy. Again. Yeah. So I think you know the situation when you come to a company. So you're a new employer, you came, and you got a piece of code which was written 10 years ago. So with some kind of that stuff. So it's a problem, but once you solved it, either you already divided it into parts, either you already rewritten it from scratch, and you have all the parts in a way it have to be. So you have microservices, modern design. You can put these to different things. So now we can go to step number two to host the application. And to see what options do we have, let's recall the history. So from very beginning to see how it was many years ago and what we have now. So only proper tools will bring you to success. So yeah, bare metal. So years ago, we were hosting bare metal. We were running our Java applications directly on bare metal. Then a big, huge step forward was done by virtualization. So once we had virtualization, we were able to isolate our processes from each other. We were able to run multiple applications inside one hardware server, but then we were improving all the time. We had new technologies. Then cloud computing, it's when you already can host your virtual machines, but not on your site. Somewhere you don't even care where they are. So then people started to get smarter. They created configuration managers, Puppet, Ansible. So have you ever worked with Puppet, Ansible, Chef? Yeah, right. Very nice thing. You can just take an absolutely clean VM with a CentOS, Linux, whatever, Solaris. You can run these scripts, and you got your configuration manager to make your configuration in a way you want it to have it, to even deploy your application. So it's like a next stage, service orchestration. So when people became even more smarter, they tried to manage services as a small individual parts, independent parts. And if you are still running on bare metal, your application, it's absolutely impossible to manage small services. There can be hundreds of them directly on bare metal. So that's why we need to understand why containers are so important to be used today. So containers. Could you please tell me who from you already worked with containers? Any kind of containers? Great. On that part? Wow, there are many of them. Okay, so you know that containers are the kind of technology that allows to isolate processes. So it's not a virtualization in a plain sense where you emulate the hardware. So it's a kind of way how the operating system acts. And the containers, container itself is not a new technology. So many people think that Docker invented container, that open container invented container. No, so not that project, not Docker. The containers are existing for many years. So even in Solaris, there were Solaris zones. In FreeBSD, there were jails. So containers are really almost 20 years old technology, but it is always improving all the time. And let's try to understand why the technology is so important even today. Because 20 years ago, when the containers were invented first time, it wasn't so obvious how we can use them and why it is so important to use it nowadays. So, reasons. Yeah. Before reasons, let's clarify some details. So, container is the kind of isolation, process isolation, and the ability to add limits to that process. So there are two mainly basic categories how containers can be. So that can be a system container or container from a point of view like Docker or open container. So when you isolate only a single process and you just manage the process, basically your service, or that can be like it can act like virtual machine. So it can have a start process like init, which is running also SSH, can run FTP access, data storage, other services, also your main service. So have you ever worked with Virtuoso or Alexi? It's a kind of, yeah, you know it. So Docker is something very similar. So they're using basically same technologies like namespaces, C groups. So on a basic level, the technology is the same from the Linux side, but from the side of end user, so it's working a bit different way. So in our case, we're gonna use for our test case that I will show you a bit later. So we will use VZ containers, but that's not mandatory thing. So one important thing to understand for today is that any kind of containers is much better than virtual machine, because there still can be some reasons why you have to use virtual machine, but in fact there are so small percent this kind of situations. So usually container is more than enough, absolutely. And let's see some benefits. So container it's all about limits. So you do not pre-allocate memory or CPU resource for your process. It's just a limit. So it means as far as you're not pre-allocating anything, you can scale. You can scale container up and down in resources. You can migrate your process with the live migration technology, which name is Creo. You can put limits on fly. So, for example, if you provision virtual machine and you suddenly know that you need more bigger virtual machine, you need to do a restart sometimes, or you can only scale in one direction. And that makes some kernel processes to happen that can break your application, in fact. So, as far as containers are not provisioning anything, pre-allocating anything, we can say that if we use bare metal server for virtual machine and for container, we can put much more bigger amount of containers on virtual machine than on bare metal than virtual machine that will have spare resources unused. How it's on practice. So that's all about scaling. So it's not very mandatory to run containers on top of bare metal. The thing is that it is much more effective. But if you provision containers inside VMs, that is also fine. And in case if your orchestration software is running just on top of Google, Amazon, other services that are only working with virtual machine, that's also fine. But it's a bit less effective. Yeah, about cost. So business side should be happy about containers. Why should we pay for resources that we never use? So you bought a virtual machine, let's say, with 10 gigs of RAM or 20 gigs of RAM, and your application is using only 1 gig. So you're paying for resources you never used. With container, which is working with limits, you pay only for the used resources. You don't. That's the case if you're not running that on your private server where all resources are yours. So that's related to services like Amazon public cloud, where provisioning is working with only limits, and your money is counting only by your used resources. So that's where business side is good. And there one graph, the graph from reality. So in our company, we're doing platform as a service for hosting service providers, and we got some. We did some check. So what limit is set, and how much resources are really consumed. And that here you can see on a red line, that means the limit. So if the end user, the customer, would like to buy a virtual machine instead of container, he would pay for that resources. So that would be pre-allocated in case if he would use a virtual machine inside of container. Blue line is really what he is used in fact. So container is fantastically elastic thing that gives elasticity and give us an opportunity to scale our services in different directions. So basically there are 3 main directions of scaling. Many of you knows already about 2 of them, but the third of them is also very important. So horizontal scaling, it means that some parts of your services can be scaled. So basically some services can be scaled, running in multiple instances. And that kind of thing is a horizontal scaling. Vertical scaling for those services that is too hard to scale in amount of instances, so they had to be scaled in amount of resources. For example, database servers. So classical example where horizontal scaling works good. It's a kind of compute nodes where your application makes a calculation. For those parts where database server is used, it's better to have ability to scale, to add resources on fly, but to use vertical scaling. And topology. Topology is the thing where I started my talk from, the application, big part. So some of big parts can be like cut to smaller parts, and these smaller parts can be moved to microservices, and it means that your application ideally should be like a tree with the services with the longer branches that can be scaled horizontally, with the fatter branches that can be scaled vertically, and like amount of branches itself, because you can cut big parts into smaller parts, and as more smaller parts you have is better, it's more manageable, and as we can put the elasticity of container on top of that branch, it gives a fantastic results. If we compare virtual machine with the container, it's from the perspective of space. I like space. Space always is a good example. So spaceship. So when you are in a space, you have a environment where you can live. It's a spaceship. It's a big, huge spaceship. Container is like a costume which you can put on. So you can travel in space either in big spaceship, either in a costume. Costume is more easier, lighter, much more comfortable to use than if you just will do big movements with a spaceship. So that's something kind of this. And let's go further. Templates. So we were talking about Puppet, Chef, Ansible. As far as you provision a virtual machine, it takes time, and then you need to put your configuration there. With containers, you can use predefined templates that makes provisioning much more faster. So such things like Ansible, Puppet, Chef are really not needed anymore, because orchestration software can do everything else, and the templates can be just packed to a smaller images, which can be just spinned on fly very quickly. And one of concerns we were always facing with, what is better? So if you run in your application in, let's say, 5 instances, and you want to scale, what is better, to provision container from scratch, or to clone existing application, existing container, to have another copy? And you know, in fact, these approaches are good, and it depends more on your application, because sometimes it's much more faster to provision new instance from scratch, to put an application, because you already have template, so it's a runtime for its JVM, all the configuration files that are managed by orchestration software. So you need just to put the WAR file or ER file, and we did it. From other time, if it's not a plain Java application, but a kind of more complicated application, it's better to have a clone, and it is faster to have a clone. So today we will see how that works in real. So another good thing, continuous integration and delivery. So just imagine your legacy software on big bare metal server or on manually installed virtual machines, and you need always to do such things with development. You need to give the software to QA, from QA to pre-production, then to shift the application to production. So with containers, it works really much more faster, easier. And as far as containers are easy to clone, to migrate, that makes the magic happen. And yeah, that is what is related to application. We were talking from very beginning. So as far as application, we need to try to put each service to a separate container, because there are no reason to put multiple services inside a single container. Moreover, if these services are not related to each other. So the rule, one of rules, each service, each separate container. It doesn't matter if the service, that wouldn't be more harder for the hardware to run 100 containers than 100 processes inside single container. So for the hardware and for consumed resources, it really doesn't matter. So each service, each separate container. Boom. Yeah. So not a marketing thing, really. Not a marketing thing, because there are many orchestrators available on the market. So Mesosphere, Kubernetes, Jelastic, many others, Tectonic. So each orchestration software is good for its own reasons. I'm sure for real reason that our orchestration tool is good. I will show a fast demo how that can be configured on our orchestration software. But the thing is that it's not mandatory to use a certain orchestration software. So all these things are also possible on any other. So if you are free and you are good with Kubernetes, it's nice. If you're good with Mesosphere and Mesos, that's also fine. So you should choose the tool which is suitable for you, because I met some situations. So for those guys who wanted to use Docker everywhere, they tried to make the application be suitable for the Docker. That's a wrong approach. Docker is a tool. tool, but change the application to work with the tool, the stupid approach. We need to change the tool to work with this current application, or choose another tool if that tool is not good for you. So in case with the platform, we will work with GlassFish. So classical thing, many years ago, GlassFish, when it was living inside their virtual machines or bare metals, classical scheme is the main admin server, worker instances. As you can see, they are limited with virtual machines, so you can, so typical problem of this architecture is you are running instances inside virtual machine. That suddenly you know that you need more resources. You add extra machine. If you know that you need a bit more resources than you already have, you still have no choice, and you choose another machine, and then you have then the load on other instances is decreased, and you have some of virtual machines are underloaded, other virtual machines are overloaded, and you cannot fast move, change limits inside, not limits, but allocated resources for your virtual machines to make your instances feel comfortable. If we were using containers, yeah, like this. So we are not limited with the amount of pre-allocated resources. So it's only about limits. And containers itself can take more resources if they need it, or take less resources and share other memory if it is not needed. So in fact, the picture will be looking like this. So it doesn't matter even how many hardware you have, because you can scale your layer. Let's call it layer, because nowadays it's hard to talk that container, application, service. So it means layer. So in case if your service is scalable, we are talking about layers. So if you have load balancer, it's bad to have only one load balancer. It should be a layer. So the number of instances of load balancers, because come on, single point of failure in 2017, it's really bad, and there are no reason to have it. So we have everything can be clustered, and using live migration, using containers, it's easy just to add hardware on fly, to migrate containers from one hardware node to another hardware node. So live migration is a super cool thing about this, because once you see that you reached your limit on a hardware server and you just got another hardware server, it's easy to put your workloads from one node to another node by freezing processes and migrating them. So you know, VMware had a technology called vMotion that migrated the whole virtual machine. Who migrated the whole virtual machine with vMotion? It takes ages. It really takes ages. If you can just take a process and migrate it to another node, it is 1,000 times faster. So such kind of thing allows our GlassFish server to be scalable. And yeah, so load balancer is also a scalable thing. So don't take a look that it's only a single node that can be scalable. Even more, so orchestration software allows to gather metrics and see once you have reached the load for your current existing instances and can provision new one, then it can remove instances in case if you don't need any more resources. So why it is good thing? I do remember the situation from my life. So we had a big cluster, and suddenly the customer had a TV show that it was maybe 10 years ago, and we were not using containers for sure. So that was a problem. Suddenly, customer got TV show. After TV show, he got big traction. Many customers came. Our team had to create virtual machines all the night, install software, make it connected to load balancers. Then the traction disappeared after a day or 2 or 3, and then you had to remove these nodes because they are not used anymore. So you spare resources. That's bad thing. So everything that can be automated should be automated. And if it is already done for you by someone else, there is no reason to do it again. So if you suddenly decide to write your own orchestration software, come on, no reason for that. Use already existing open source software, commercial or open source. Guys from Koreos also has very nice orchestration software called Tectonic, but it is commercial if you want to use Kubernetes. So by the way, Kubernetes are not using only Docker. So there is another trend in the world called open container. So many guys from all the world just created a project, and there is alternative to Docker implementation, but on basis the technology is the same. And Kubernetes can now manage open containers as well. So no, Docker is not mandatory thing. Docker is a commercial company with its own open source tool, but anyway, it's not mandatory. So Kubernetes is free, Mesos is free. Mesos can also use open container, no problem. So don't do the job twice. Everything is automated for you already, so just can start and use this. Database servers. Yeah, database servers can be scaled as well. And in this current example, you see there is a Proxy SQL. You will say, why do you need Proxy SQL as GlassFish server supports connection pools, and you can put multiple connection streams directly there? That's true. Let's call it lazy. It was so just spare work to write some API calls just to connect the new instances on fly. So Proxy SQL is a kind of alternative when you can just do this thing easily. By the way, the project is also well developed nowadays. Very small demo, so how it's actually practically can be done using orchestrators. That use case is super simple, so extremely simple. We just take their GlassFish node, create a cluster, connect it to database, deploy application, then scale, because we don't need a single point of failure, and then clone environment, because, for example, you wanted to do CI/CD and you don't need to do that from very beginning. If once you already configured your application, no reason to do it twice. So you can just, or another thing, CI/CD, it's one case. Another case, for example, A/B testing. So if you want to have the clone of your existing application, actually infrastructure, and you want to put some users, just some percent of users to this new application to try out some things, so that thing can be done by orchestration software. No reason just to do something, to write something that can be just done with a mouse click. And once again, it's not a marketing, so just to show you how that can be done with the orchestration software. So that's kind of panel. We just choose GlassFish, JDK 1.9, okay, that's fine. Creating with a minute. We log into to GlassFish panel. The panel is the same. We can see that's a standalone node. We just need to provision cluster. No reason to install it from scratch. We have templates. So just go to GitHub, take the manifest, and say, I need a cluster, okay? It's a cluster. It's done. Then we take the dump. Very usual way, we just put this dump inside. Nothing special is here. Then we go to GlassFish, connect it to database. Very straightforward. And then it's done. So we have typical cloud, typical application. So it's a single instance, domain admin server, and their database nodes. So deploy an application. Once you already have your structure, which can be in fact really much more bigger than this simple example, you need to put your application inside. So no reason to do something configuration. You just deploy it with our orchestration software if that is a managed container. So another thing. So container can be a smart container or stupid container. In case if you're working with Docker in the most simplest way, you pack your application inside image when you're then starting. It's a kind of stupid container. But there is a way which is also done on Cloud Foundry and Elastic, where their logic, which is also OpenShift, which is managing the application from inside the container. So there is a kind of application which is running inside of container and can put the application to its runtime. That saves time. No reason to repack your Docker image from scratch just to put a new WAR file, because every time you will put your new WAR file inside an image and spin it from again, from where again, it will take time. So there are many things already automated for you in any orchestrator. No thanks to do it from scratch. The same as for scaling. So you just click plus button, or in case of Docker, you just said replicas equal 20, and you have 20 either cloned nodes, either provisioned nodes from scratch. So that makes things pretty easy. And orchestration software already can reconfigure your application server to be for cluster mode. So with no reason just to go and just to click something to change settings. So orchestration software already does this. And traffic distributor. Such things are available everywhere. That's a tool allows you to manage traffic. For example, you had one cluster, you need to do A/B testing, or you need to have QA environment. You need to be, for example, or you want to have failover in case if one data center is down, you want to forward your traffic to another data center. Traffic distributor things are used, so that can be also installed with a click. Nothing very special. Oh, come on. Sorry. Yeah, so as you can see there, it's pretty simple. You set amount of instances. So we are not working with single point of failure, no reason for this. So amount of instances, 1 load balancer, 2 load balancer, 3 load balancers. So then it direct traffic to other entry points. Then these entry points direct traffic to your instances or your services. So such kind of things are already written. In case of Kubernetes, it uses discovery. So your instances are also, once your instance is added, their IP address of this instance is added to a special key value storage. This key value storage is used by load balancer so load balancer on fly knows how many backends does it have and which of them can be used with health checks and all the stuff. So that's a usual practice. So the goal of this topic, okay, doesn't matter. So the main idea is, do not recreate the bicycle from the scratch. No reason for this. There are millions of projects in GitHub where everything is done before you. So once you start working on something and you need to put your legacy on a correct rails, just check what is already invented for you. So first thing, proper design of application to make it run. Second thing, containers. No VMs, containers. And third thing, proper orchestration tool. That can be Kubernetes, that can be Mesa, that can be Elastic, that can be Tectonic, whatever orchestration tool. So yeah, as far as you have all these three things, you can say that it's your application should be should run in more efficient way, because really, 2017, and the situation still happens all the time when the customer came and said, hey, I need 3 bare metal servers, Heartbeat, KP Live, and etc., and I need to put it services here, and you're just looking, man, where you been sleeping for last 10 years, in which cave? Many things happened in IT industry, things are happening all the time, very fast. Today we're gonna sleep at night, some of us, yeah. In the morning, 100 of new projects will be written. And from that 100, 90 of them can be open sourced. And no reason to do things from scratch. So many things already done. Thank you for your time. That's all from my side, and was glad to see you. Thank you.